Hey guys, in this tutorial I'm gonna show you how to generate mesh for the interconnected cylinder example. Well, after drawing the geometry, you're going to the mesh section, and as you all know, we have many ways to generate mesh, including tetrahedron, hex meshing, multi-zone, and sweep. Well, sweep is the best way to generate Sweep is the best way to generate mesh for cylinder shape geometry. Well, but the sweep is not capable for complex geometry like the one we have right now. So first of all, we have to check. But for doing that, we're going to the mesh, right click on it, we're going to the show and sweepable bodies. The sweepable body is gonna show us the bodies which are capable of the sweep method. So as you can see, there is no body which we can use sweep for it. Therefore, we let the ANSYS Fluent decide which method is the best for the mesh. And for that, we're going to insert method. We're going to select the geometry, and we're going to choose the automatic method for generating the mesh. For sizing, we're going to go insert sizing. We're going to select the geometry, and for type, we use element size. And for element size, we're using 0.01. And since this is the pipe, the mesh near the wall is very important. So we're going to use inflation for near the walls. We're going to the mesh, insert, inflation, and for geometry, we're going to select the interconnected cylinder. And for the boundary, we're going to choose all the faces. And for the maximum layers, I think 5 is okay and you don't need to change it. And for the growth rate, change it to the 1.5 and then press OK, and then press generate mesh. So this is our mesh right now, and we can check the number of elements by going to statistics. So you can see the number of nodes and the number of elements here. We have about 163,000 elements. And let's look at our mesh. So let's zoom on it. So we have a TET mesh inside the cylinder, and we have 5 layers of the mesh near the wall. We can also check inside the mesh by going to the section plane. So for that, we're going to the mesh, and we're going to the home, section plane, and right now we need to draw the plane that is gonna cut the mesh, cut the geometry in half. So this is the inside of our domain, and we can see the inside the mesh inside our domain. So as we expected, we have a TET mesh inside. We have a combination of TET and wedge meshes inside the domain, and 5 layers of inflation near the walls. We can also check the quality of our mesh by going to the mesh metrics display, and we have many options to check the quality of our mesh, including element quality. The element quality is gonna show us the type of our meshes, and we can also check the skewness of our mesh. So as we mentioned in the class, for a good quality mesh, the skewness must be lower than 0.8. And for this mesh, we have a maximum skewness of 0.74, which is lower than 0.8, and this is great. But skewness and is not the most important thing to check. The most important thing for a mesh is the minimum volume, and our minimum volume of element should be positive. For checking that, we need to save this and then close this section and go to the setup section. Setup section is the place that you use Fluent for simulation of our case study. So we have our mesh ready. So to check the minimum volume, we're going to check perform mesh check, and you can observe the result in the console, and you can see the minimum volume is positive, and this means that our mesh is good and we can use it for simulation.